Okay, so starting section 4.4, we are going to continue to build off of solving equations. We have been solving equations with the variable just on one side of the equal sign. Now we're going to start looking at it when the variable is on both sides of the equal sign. So we're going to be solving equations in the form ax plus b equals cx plus d. A, b, c, and d are just any real numbers. So the variable in this case would be x, but a, b, c, and d just represents numbers. By the end of the chapter, I do expect you to be able to solve a problem similar to this. Nebraska's population had been increasing at a rate of 13,300 people per year and reached 1,711,000 in 2000. West Virginia's population had been increasing at a rate of 1,400 people per year and reached 1,808,000 in 2000. If the rates of increase do not change in the future, when will the populations be equal? So we have two situations going on here, and we want to know when will those populations be equal. So again, by the end of the chapter, I expect you to be able to come up with an equation for this problem and to be able to solve it. So that's kind of the goal, what we're working towards. Now this video is a little bit different in that you don't have guided notes. So you are going to need to take notes from the very beginning. So in fact, you may want to rewind and go back to the beginning and copy this down. So at any point in time that you need to stop and copy down, do that. What you will have to copy the notes down. So you're taking notes on your own just as you would in class. Okay, so here's the goal. If there's a variable on both sides of the equation, then we want to get the variable to one side of the equation, and the constants, and constants are just numbers, to the other side. Then we solve by isolating the variable exactly how we have been doing. So again, the goal, two variables on one side, get the variables to one side of the equal sign, and the constants, the numbers, to the other. So a constant is always just a number. So for example, 7 is a constant because 7 is always 7. -5 is a constant because -5 is always -5. The variable is always changing. So the general form of a linear equation is ax plus b equals cx plus d. So again, a, b, c, and d are just real numbers. Notice we have an x on the left and an x on the right. So let's just go ahead and start looking at some of these problems. So again, stop the video, copy this down, copy each problem down. So we're going to solve each equation for the given variable. So we have 10x minus 16 equals 4x plus 32. Well, I have an x on this side and an x on this side. I still want to look at the left side, can I simplify anything? And the right side, can I simplify anything? So you always want to simplify the left and simplify the right side first before we start moving things around. So, I can't simplify anything. These don't go together. They're not like terms. The -16 does not have an x with it. 4x plus 32, not like terms. 32 does not have an x with it. So now what I can do is start to move the variable to one side, the numbers, the constants to the other. There's several different ways to start this problem, but I'm just going to give you one way, okay? And we can discuss more in class tomorrow. So my goal is going to be to move the variable to one side. So I have a 10x and a 4x. I'm going to move this 4x over here. So because it's a positive 4x, I want to subtract 4x from both sides. And notice how I keep everything lined up as far as like terms go. I line up my x's so that way I don't confuse myself any more than needed. So then 10x minus 4x is 6x. I just bring down this -16. I haven't done anything with it, equals 4x minus 4x is 0, 32. We have now created a problem that we have been working with for a long time now. So I've got the variable on one side. Now it's just a matter of starting to isolate the variable and get it by itself. So I'm going to move those constants, move those numbers to the other side. So I can add 16. So I bring down my 6x. -16 plus 16 is 0 equals 48. What do I do to get x by itself? Divide by 6, because 6x divided by 6 is just 1x. And we know 1 times x is just x. So x equals 8. Now how can I check this? If I go back to the original problem and plug in 8 for x. So 10 times 8 minus 16 equals 4 times 8 plus 32. I'm basically asking, because I'm checking, I want to know, is my value for x correct? Does the left side equal the right side? So I have 80 minus 16 and 32 plus 32. Well, 80 minus 16 is 64, 32 plus 32 is also 64. So I know I got it right because when I plug in that value for x, the left side equals the right side, and that's what an equation is. It's completely balanced. Left side must equal right side. So that's the first one. The next one, again, continue to stop the video as needed. You need to get these notes copied down with the examples. So 21x minus 9 equals 11x minus 39. Again, hopefully right off the bat, you notice I've got a variable on the left side and the right side of the equal sign. Can I simplify the left side? No, not like terms. Cannot simplify the right side either because they are not like terms. So what's the goal? Variable to one side, numbers to the other. So let's start moving. I can move my 11x over here. It's a positive 11x, so I want to subtract 11x. Now, could I start by first subtracting 21x? Absolutely, but again, we'll talk about that tomorrow. We could even start with adding 9 to both sides or adding 39 to both sides. But again, I'm just going to focus on moving the 11x at this point. Again, multiple ways to solve these. I'm giving you one option. So again, I've lined up my like terms. So 21 minus 11 is 10x. Haven't done anything with this minus 9 equals 0 minus 39, which is just negative 39. So again, a problem like we've been doing. So now, isolate the variable, get it by itself. So how can I get this alone? Add 9 to both sides. So I have 10x plus 0, which is just 10x. Negative 39 plus 9 is negative 30. What do I do to get x by itself? Divide both sides by 10. 10 divided by 10 is 1, or 1x equals negative 30 divided by 10 is a negative 3. And again, to check the problem to see if you got it right, you take your solution and you plug it directly in for x. Simplify the left side and the right side. If it is correct, if that value is actually a solution to the equation, it makes the left side equal the right side. Next problem. Again, you are still copying down these notes and following as we go, stopping and pausing and rewinding as needed. 24x equals 16 minus 8x. Okay, there's that variable again on either side of the equation. Can I simplify the left side? No. Can I simplify the right side? No, they are not like terms. So let's move the variable to one side. Now here's the thing. Yes, we could subtract 24x from both sides, but then I end up with the variable and the number on one side. So the easiest thing, what probably makes the most sense, would be to go ahead and add 8x to both sides. That way I end up with a variable on one side, constant on the other, because remember, that is the goal. Get the variable to one side, constants to the other. So this is a negative 8x, so I want to add 8x to both sides. 24x plus 8x is 32x, equals 16 plus 0, so don't need anything else there. How do I get x by itself? Well, that's 32 times x. So I undo that by dividing. 32 divided by 32 is just 1. So x equals 16 over 32, which reduces to 1/2. So x is equal to 1/2. Again, how do you check that? You plug it in for x here and here. Make sure left side equals right side. Next problem. 8n plus 5n minus 12 equals n. So I look at the left side. Can I simplify? Can I condense anything? Absolutely. I have like terms. I have 8n plus 5n. Same exact variable, same exact exponent. So 8 plus 5 is 13. So I get 13n minus 12 equals n. Can I simplify the right side? No. So what makes the most sense in this equation? Knowing goal is to get the variable to one side, constants to the other. Well, if I subtract n, now I've got the variable and the number, the constant, on one side. So why don't we start this one by subtracting 13n? That way, I end up with, remember there's a 1 there, 1 minus 13 is negative 12. That enables me to have constant on one side, variable on the other. So again, it doesn't matter if the variable's on the right or the left. That's just going to totally be up to you. But again, I did that just to kind of go with this whole idea, get the variable to one side and constants to the other. If I move this n over, I've got the variable and constant on one side. But you can still solve it. It would just be set equal to 0, add 12, and then divide by 12. So anyway, still going along with this. We combine like terms. we end up with, we subtracted 13n, we end up with negative 12 equals negative 12n. Get n by itself, so I divide by negative 12 because it's negative 12 times n. So negative 12 divided by negative 12 is 1, or 1n. Negative 12 divided by negative 12 is a positive 1, so n equals 1. Which, realize you can rewrite that as n equals 1 as opposed to 1 equals n if you do like that variable on the left side. Now it doesn't matter, we don't have to pay attention like we did with inequalities about that, is it on the left side or the right side. So this is the commutative property, or actually the symmetric property, where if 1 equals n, then n obviously equals 1. So that's your symmetric property. Okay. Now, here's your homework. I want you to try to solve the following problem for the given variable. If you need to rewatch the video, do so. If you need to go back and take a few more notes, do so. But I expect to see notes tomorrow, as well as this problem. So do your best, solve it. Let's see what you come up with. See you tomorrow in class.